In this lesson, we'll be discussing how to find the range of a rational function involving quadratic expressions. For example, if we are given that our f of x is equal x squared plus 1 all over x squared minus 4x plus 5, find the range. Solution. We know that the range, which is the y values, is the set of y values for which a function is defined. So it is the y values that makes this function defined. So we would solve this in terms of y. So we have that y is equal x squared plus 1 all over x squared minus 4x plus 5. We can cross multiply here so that y multiplies the denominator. We are going to have y multiply x squared minus 4x plus 5 equal the numerator x squared plus 1. We can expand here to have that our y multiply x squared will give us ys squared minus y multiply minus 4x will give us minus 4yx. Y multiply 5 will give us plus 5y equal x squared plus 1. We now collect like terms and equate the expression to 0. So we have that our yx squared minus, because this crosses over the other side, it becomes negative minus x squared. Then we continue from here, minus 4yx plus 5y, and we have 1 left. It crosses over, it becomes negative 1. So we have minus 1 equal 0. Okay, we can factor out x squared here to have that our y minus 1 multiply x squared, because y multiply x squared will give us ys squared, and minus 1 multiply x squared will give us minus x squared. So that is sorted. We now have minus 4yx plus 5y minus 1, everything equals 0. This gives us a quadratic expression. We know that quadratic expression is of the form ax squared plus bx plus c, right? Where our a, b, c, a and b are the coefficients and c is the constant. And we can see from what we have here that our a, which is the coefficient of x squared, will give us y minus 1, and our b, which is the coefficient of x, will give us minus 4y, and our c, which is the constant, will give us 5y minus 1. So we can eliminate the x values. And how do we do that? Using the discriminant. The discriminant formula is b squared minus 4ac, because discriminant focuses only on the coefficient. So our b squared, which is minus 4y, will give us, so we are going to have minus 4y squared minus 4, in our a is y minus 1, multiply c, which is 5y minus 1. So minus 4y squared will give us 16y squared minus, if we expand y minus 1 and 5 y minus 1, we are going to have, let's do this here, we are going to have minus 1. Let's y minus 1 multiply 5y minus 1. Okay, y multiply 5y will give us 5y squared, and y multiply minus 1 will give us minus y, and 1 multiply minus 1 multiply 5y will give us minus 5y, and 1 multiply minus 1 multiply minus 1 will give us plus 1. And we have 5y squared minus y minus 5y will give us minus 6y plus 1. So we will plug in this in here. We are going to have 5y squared minus 6y plus 1. We can expand this function to have that our 16y squared minus 4 multiply 5y squared will give us minus 20y squared, minus 4 multiply minus 6 will give us plus 24y, and minus 4 multiply plus 1 will give us minus 4. So let's go ahead and solve the remaining part of the equation. We are going to have that our since we are having 16y squared minus 20y squared, if we put that together, we are going to have minus 16y squared plus 16y squared minus 20y squared will give us minus 4y squared plus 24y minus 4 equals 0, right? So we see that we can factor out 4 here in this expression, and we can have minus 4 in y squared minus 4 divide 24 will give us 6. Okay, so we have minus 6y, and minus 4 divide minus 4 will give us plus 1. Okay, plus 1. All right, so if we solve the inequality, we are going to have that this will be greater than or equal 0, so that we are focused on y squared minus 6y plus 1. Minus 4 will be greater than or equal 0. So we discard that. We only focus on this, which will mean that our y squared minus 6y plus 1 will be less than or equal 0. Just like we have that minus 4 will be less than or equal 0. And this is a quadratic equation. We can use formula to solve at once. And we have that the coefficient of y squared here is 1, meaning that our a is 1, and our b coefficient of y is minus 6, and our c is equal 1. Using the formula that our y will now be minus b plus or minus the square root of b squared minus 4ac all over 2a. And minus 6 is our b. Minus minus will give us 6, plus or minus the square root of 6, the square root of 6 square minus 4. Our a is 1 and our c is 1, everything all over 2a. A is 1. So the final part of the function will give us that our 6 plus or minus 6. So this will imply that 6 plus or minus 6 square will give us 36 minus 4. 4 times 1 times 1 is 4. All over 2 times 1 is 2. Okay? This will imply that our 6 plus or minus 36 minus 4 will give us 32 all over 2. This implies that we can get the highest perfect square here, but you can use calculator from this point to solve if you so choose. But let's continue. We are going to have 6 plus or minus uh, 32 divided 2 will give us 16. 16 is a perfect square, so that's the highest perfect square. So we have 16 times 2 all over 2. All right, so this will imply that 6 plus or minus the square root. The square root of 16 is 4. So we are going to have 4 remaining root 2 all over 2. Okay, and therefore our final answer, we are going to have 2 can cancel 6 and 4. 2 cancel 6 will give us 3 plus or minus 2 in 4, 2 root 2. Okay, and it implies why in interval notation we are going to have therefore that our 3 plus 2 root 2 is less than equal y less than equal 3 minus 2 root 2, and this is our final answer.